Assalamu alaikum wa rahmatullah. Welcome everyone to IE 203 Introduction to Industrial Engineering. And here is the part 2 of operations engineering or operations research that we are going to cover in this course. We have talked in the first part about operations engineering in general. We named and listed some of the methods and the tools, concepts that use under the operations engineering. We covered the linear programming in the first part, and here in the second part, we will talk about the simulation. Simulation is very widely common to be used, especially in the industrial engineering, and nowadays also in other fields like mechanical engineering, also in the architectural engineering, they do it. Simulation, why we do the simulation and what is the concept first before we go with the definition. Look into this layout here of a hospital where is the emergency and there is the registration, and then we have minor treatment rooms, major treatment rooms, then we have to the other departments in the hospital, labs, x-ray, radiology department, nurses station, the doctor station. If you are going to evaluate how the process inside the emergency or the hospital, you would like to do changes in the process, you want to analyze your process, you want to forecast how is your process would perform if there are more patients come, you have lack of these rooms, you have lack of those rooms, in some departments, the lack of resources in the doctor station, you have less doctors or more doctors. All these scenarios and changes in the system, it's hard to evaluate it manually for every scenario, but the simulation allow you to do that, allow you to evaluate, to study, to even predict your system and analyze it. So the changes, even you are going to do it or plan to do it, you can do it in a simulation model. So that will save you a cost of implement it in the real life, and maybe it will not work. So you can do these changes here, like for example, changing the layout or the process flow, or changing the resources, the number of the minor treatment versus the major. Changing, as we said, the layout, maybe the departments or needed labs or radiology, where are they located? So you reduce the traveling distance, so you optimize your processing time, and so on. You can name it. يعني utilization اللي هو الاستخدام الأمثل وأتمتة العمليات has a various of application in any process or in any sector where they're manufacturing or service. Simulation will help you to see the real life scenarios if they are changed in the terms of the parameters, so you can predict, you can analyze, you can make your decisions and apply scenarios without implement them in the real life. So this is in general how the simulation works. What's the definition of the simulation? Simulation, it's an attempt to duplicate the features, appearance, characteristics of real systems. Duplicate. The word duplicate, we know that duplicate is like you are making a copy, يعني نسخة طبق الأصل. Of what? Of the real system. By what? Duplicating features, appearance, and characteristics. يعني either or. All of them or one of them. Characteristics, appearance, features, المواصفات اللي هو الشكل الظاهري للممكن للعمليات، الخصائص للعمليات like time, number of resources, how the flow works, the steps. So all these can be duplicated of a real life system. Okay, now the question may come, obviously, why we do that? What the benefit of doing a simulation? Here are the answers. Now, either one of those, or all of them, or some of them, all these answers why we do simulation: to imitate real world situation mathematically, and the word mathematically is important because you are going imitate تحاكي um, تحاكي the real system اللي هو current system السيستم الحقيقي but mathematically, so you can تحاكيه بنظم رياضية أو موديلز رياضية تحسب لك القياسات اللي تحتاجها needed requirement or needed measurements to study what? The properties and operating characteristics, المميزات والمواصفات for your operations, خطوات العمليات والخطوات اللي موجودة عندك. So you study them and also to draw conclusions and make decisions based on the results of the simulation. So you can make conclusion, either you do changes, you can reduce or increase resources. So all these, why we do the simulation: to imitate, to study, to draw conclusion. Study what? The operation, or imitate the real situation mathematically, and also to draw conclusion and making action. This is the use of simulation. The application of simulation is various and widely used, and by the improvement in the technology and the software application, now even the application of simulation gets wider and more. For example, now in the architectural programs, they have building modeling simulation. So instead of calculating the quantity needed for the اللي هو خلينا نقول الاسمنت raw material for يعني building عمارة or your house, this building modeling simulation can do all the calculation in the actual layout of your building. So you can see it 3D, you can adjust the window size, you can adjust the electricity, where are they, and it adjusts all the quantity needed for the material, the related material. So this is another dimension of application. In the industrial field, name it, you from the manufacturing until to the service or healthcare, you can do application of simulation for the routes, for the plant layout. You remember that we have talked about the plant layout in the manufacturing systems, or also here in the example of the hospital. So you can use the simulation to run the process, how it will be in the in your layout, so you can optimize the working floor and you reduce the traveling time. For sales forecasting, توقعات المبيعات, inventory planning اللي هو التخطيط والتحكم للمخزون. Many taking different application to show you how widely is it it can be implemented. Even the voting اللي هو نظام الانتخابات, you can predict it using simulation based on historical data. Bus scheduling or delivery scheduling, you can use the simulation, the traffic light, the crowded in the highway, processing, production scheduling, the facility scheduling, all that it can be done using simulation, or as an example of application of simulation, and many others. Even the car engines or lifespan of equipment or machines, it can run through simulation, so they predict failures when it happens and predict the time of the breakdowns. And that's, you see why there are some cars giving you the warranty for 100K or 5 years. These are not arbitrarily, يعني, they give it to you. They are calculated, these warranties, based on simulation model for running the major parts in the car for over the time that they give you the warranty, and estimate the failure when it happens and the cost of the failure. There is a probability of failure happens definitely before the warranty, but when they establish this specifically 60,000 kilometer or 100 kilometer, 1,000 kilometer, and so on, whatever was that, this is basically, but also using simulation is not something random, they just do it. So they expect the majority of failures when it happens, and they usually do it is just on the edge where after that the common failure can comes. So that's why after the warranty, you see the problems comes more and more, and you start paying and fixing your car. But doesn't mean that there are nothing that break down during the warranty. It happens, but this is all calculated, the same thing, and it's already, they got that from the price of selling your car. It's already included that the fixing during the warranty somehow. So I'm giving a big picture here how even the simulation can go, and even the airline industry, they use it for the routes of the airplanes, scheduling the airline flights, and so on. All that can be an application, so you can see how widely they use it. I remember when I was working with the project in Disney World, it's one of the biggest company that use simulation, and they hire industrial engineers. They do simulation for every single process, even for the tickets, purchasing, for the guests that they come overseas. How is the lines, the processing time for the lines and the queue for their theme parks. So the application is wide, and the advantage of using this simulation are many. They are not limited to the one here, but those are common as all methods. There are pros and cons for the methods. Depends on your resources, your objective. Then you decide about to do simulation or no. For example, the simulation used to analyze a large and complex real-world situation that cannot be solved conventional models. Is not going to solve, pay attention here, it's going to analyze. Then it will help you to choose the right solution to solve it, and find out where it needs your solution to be implemented in your situation or your process. Now, you have a complex process and you have multiple of steps and multiple of processes integrated with each other, or equipments work with each other. Analyzing those systems manually, it will be hard, but using simulation, it will help you at least to have an overview how this system will work, and you can predict where you can have to, or where you have to focus on improving. Real world complications can be included. يعني التحديات والصعوبات اللي هي التعقيدات اللي بتشوفها في الريال لايف you can include it in simulation. All assumptions can be done there. Time compression is possible. What does it mean? يعني ما بنضغط التايم. هو الفكرة إنه you can run simulation over years in seconds. So you can get the results of how if this system works for 100 years or 100 hours, or let's say thousands of times, or of products being produced, or airline schedules being done. So you can here elapse the time, move it in the simulation easily by just clicking the number of times that where you are want to see your process, how it will be there. And that's the meaning. What does it mean? The time compression. يعني بالفكرة ضغط التايم هي انك بتسرع انك تشوف النتيجة بشكل لحظي في السيميليشن. Where it's in the real life, if you implement it, it will take years maybe to see the results. Allows for what if, and this is very important really, and this is a unique thing about the simulation. You can apply scenarios. Okay, what about, for example, here, if we go back to this here layout of the hospital, what if I, instead of having 7 or 8 here rooms, what about if I have 2? What about if I have 7 major treatment rooms? What about if the station of the doctors were next to the nurse? How the working will be affected, or the process will be affected? What about if the major treatment rooms, they were aligned next to the minor? I'm just giving assumptions here, how the process will be affected in terms of the processing time, in terms of the workflow, and all that. All these scenarios, if I'm going to implement it in real, it will be, imagine you are going to close here and open some rooms, and things will definitely take time to be implemented, and it's maybe not feasible to do it. But when you have in the simulation, you can do that easily, and that's what does it mean. What if scenarios, كل السيناريوز المحتمل you can run it, and you see quickly the evaluation of those scenarios. Does not interfere with real world systems. What does it mean? You are not going to affect your real system, because you are going to do this independently in a separate, like a software application or something. So you are not going to affect your current system, so you can run all the simulation without doing changes in real system until you get the results and make your decision. What about the cons or disadvantages of the simulation? Can take a long time to develop, as it can analyze complex system, but developing complex system in simulation, it may take time. Depend on the complexity of the system you have, the time will be changed, and also depend on the skills of the person who is working the simulation, how he's skilled in developing the model. It's a repetitive approach that may produce different solutions in repeated runs. Maybe you think, okay, what about these solutions? Are they accurate? Well, nothing will be as when you do it in real life, but doing things in real life, it may cost. Here, the simulation, it's relying on historical data or probabilities, or both of them, of occurrence. احتمالية وقوع أو حدوث الشيء أو ظهوره، أو appeared in your system, whether it was time, whether it was completion of process, whether failure, name it. So as it's a probability of occurrence, there is also probability of not occurring. مثلا, for a simple example, a dice, زهرة نرد, has 6 faces. When you throw it, you have a chances of 1/6 that will come on the number that you have selected. If you selected 3 numbers, then your chances will be higher. So as there is a probability, there is another probability that it may not occur, but now depend on the technique and the type of simulation you're working on. But if you are working a large historical data, and you have your characteristics specified correctly, and you run the simulation model for a long time, the difference changes in the solutions, it will not be that big, or it will be that large. And at the end, as I said, it's a tool for prediction, and things maybe in the real, it may differ, but is not going to be a major difference than that if you have done all the assumptions and all the inputs and the process model, you have built it correctly. So no constraints was missed or something. And talking about constraints, that's why you see here the disadvantage. It could happen. Manager must generate all of conditions and constraints for solutions they want to examine. Remember when we talked in the first part about the LP, the linear programming, and when we read the problem, I said that you have to read it carefully and evaluate the objective and define it carefully, because also the constraints variables has to be stated correctly. If you have constraints or conditions or variables were not stated or modeled correctly, your simulation model may have a large difference in terms of the solutions compared to the actual. That's why it requires from the managers or who's going to be responsible on the process to generate all these constraints and conditions, because they have to be formulated and modeled into your simulation model. I remember when we talked about the example about the variables, number of chairs and number of tables, if you recall that session. And we stated that there are availability of hours, and those constraints, very simple, by the way, that was a simple example. But when we go to complex systems, those constraints, they may be very many constraints you have and conditions, and variables, they could be also very large number of variables. So those has to be clearly identified, and that's one of the things that they have to work and brainstorm and collect all the constraints and write them down to model them. Each simulation model is unique, so you cannot use the same simulation model that for plant A and just apply it to plant B, even though those two plants, they maybe do the same thing, but their characteristics or parameters or specifications, they are different. So every model is unique. Any changes you do in the variables or constraints or characteristics, it will make a different model. So but you see, the pluses and the pros of the simulation are definitely saving cost, saving time, giving you a better picture of all the scenarios if it's implemented. So the simulation, that's why it's widely used and implemented in different aspects and different fields, other even than the industrial engineering. There are types of simulation that we will also talk about, but in general, the process of the simulation is kind of systematic and applied in most of the simulation, regardless of the type you are working on. These are the basic steps or the process of simulation, starting with defining the problem, similar somehow to the LP that we covered in the first part. Introduce the important variables, المتغيرات. If you recall, the number of chairs, number of tables, number of human working, number of labor, number of raw material. Those important variables has to be identified and know them. Construct numerical model, and here is the modeling start when you do a model, whether it's a numerical, mathematical, or numerical using computer or software application. Set a possible course of action for testing by specifying values of variables. So you start putting the range of the values for those variables. يعني if we have number of chairs, then we have either put a range or exact value, depend on your case يعني you are dealing with. Run the experiment. So you start running the experiment. And now when we do run, either run by as I said, software application, or you are going to do manual. Rarely now the manual done. There are many software packages do that. Consider the results, and when you do the results here, you examine the results, and either you continue to select your action and that you are going to implement, whether you are going to leave your process and you are satisfied with your process situation, or you are going to do the changes that you have implemented in some scenarios, and you are going to take action in your process to change it. Or there are two ways back and return to previous steps, either changing the value of the variables, or reconstruct sorry يعني إعادة صياغة الموديل مرة أخرى، أو تغيير قيم الفاريبلز. يعني when you come to the results, you have three different ways. You either are okay with these results and you are going to do changes in your process, and from the scenarios you have seen in this simulation model, and you are going to take and decide about the course of action you will take in your actual process, okay? And maybe one of the action is you keep it because you are satisfied with it. The other two decision or steps after the results appeared, you may go and change the variable values, either by changing if they were a constant value، يعني 70 شخص أو 70 labor شغالين في الشركة أو في المصنع، you reduce it or increase it. Or maybe you change the range، يعني عندك shifts time and you are changing the number of people, 5 people or 10 people per shift. Or you change the model itself that you started in step number 3, and you reconstruct the model again. Maybe you have not included some constraints or conditions correctly, so you have to reconstruct the model again. So this is the process of simulation that commonly to be implemented in any type of simulation. There are types of simulation, and you will explore them more on details and separate courses and simulation courses. Here we are just touching the base of the simulation and one of those models, just to show you how it can be implemented, and basic example how we can do it manually, and to practice that and learn how to do simulation in basic problems. There are 4 types. Those are common, but there are others, but those very common to be seen. Agent-based simulation, discrete simulation. This mainly you will cover it in depth and more details in a separate course. Monte Carlo simulation, system dynamics simulation. In the agent-based, the word or the company or the process model using agents, and as you can see here, and those agent doesn't mean or doesn't have to be a human, as the picture or the logo here shows. It could be a company, so the company communicating with other, or process or machine communicating with other machine. But the concept of the agent-based is relying on the system working using agents, okay, regardless whether they are human or assets or systems, okay. For the discrete simulation, or they call it discrete event, because what does it mean? It means that the model of the discrete simulation, the process is a series of instantaneous occurrence, and in between these events, for example, between this step and that step, the event system fixed and no changes happened. So it deals with each step as simultaneously, and then for example, the changes happened between them. It's considered to be fixed. So you can calculate the time from the start here and the end here, and the start here and the end here. So it simultaneously simulate the process. For the what else? We have the Monte Carlo simulation, and that will take an example of the Monte Carlo simulation in the next slides, and we will explain it in more For the system dynamic simulation, you start with a diagram like this one here. You see how those nodes and the flow, and you see like some kind of valves. This shows you, this type of simulation shows you a structure of a system, يعني مخطط هيكلي للنظام. You don't need to learn programming here in doing the system dynamics. You need to identify how the parts are connected. For example, the transmission with the engine, the wheel with the engine. I'm talking just يعني giving example of a car. What is the input from the transmission and goes to the engine? What is the output from the engine to the اللي هو الwheel of your car, الإطارات, الenergy, for example. And then adding, subtracting from the input here and the output here. So if you are measuring the energy from the fuel that you are going to burn in the engine to your wheel, and then the remaining will go to the exhaust. يعني هذا البيسك concept of the car. بنزين وهواء بيدخل للسيارة للانجن، بيعملوا احتراق يولد الطاقة تتنقل. عملية النقل هذه بيكون فيها أيضا ارتباط مع عملية changing the gear اللي هو الجير حق السيارة، والطاقة بتتنقل للكفرات حتى تتحرك. Also the energy or the waste goes to اللي هو حق الاحتراق بيروح للإكزوست system. So imagine if this is like that, this is how the structure built, and calculate the input from the energy until the output and how it's subtracted from every step. You can count to show the accumulation in this system over time, so you can see if I have done this run over 100,000 kilometers or 500 hours working time, what will be the accumulation of the system in terms of the things that you are going to calculate, whether the energy or a material or whatever was that. Is not a static, it's a dynamic, like an organism, يعني كأنه نظام حيوي, it's working. But as I said, here the software, they don't require programming. As also maybe some of the discrete simulation now, there are some advanced software application. It doesn't need programming more than blocks, that where you have to work on just putting the inputs and the characteristics of those, and then you can just run them. Now with the technology, as there are some simulation can done by programming, as also software company developing a simulation software and a user-friendly environment, so it can widely implemented in different applications. For the Monte Carlo simulation that we will cover, because it's basic, and the others that you will cover them in other courses, the name of Monte Carlo simulation came from the city of Monte Carlo that's located in Monaco, that known for gambling, القمار, and how in the gambling that there is a randoming أو عشوائية في عملية يعني لأنها مبنية على نوعا ما, there are some kind of random and how you get the results that, or you achieve the things that you are predicted. So the name, it's pulled from there due to the randoming of this concept of simulation. It's based on random, and why the random, we can use it to do simulation. Random over time can generate a data that can use probability to predict how it will come in the future, the results. Even for those people working in let's say in places where the randoming happens. For example, breakdowns in the car, يعني فجأة السيارة تعطل. You can do Monte Carlo simulation based on historical data to estimate when the time of the breakdown of that car can happen, the time between arrival of your customers to your shop, that as it's random but also from historical data, you can do probability study and predict the future. So the Monte Carlo simulation, or MCS, used when elements exist for when the system contain elements that exhibit chance in their behavior, and that's the mean. The exhibit of chance of the behavior يعني كان توريك جزء من طبيعة عمل هذا السيستم, so you can predict how the future will happen. It's a basic model, but also it can widely implemented, and many examples can be inventory demand, احتياجات المخزون, lead time for inventory, time between machine, as we explained, time between arrival, service time, وقت الخدمة المستغرق, time to complete project activities, number of employees absent. All that can be application of the Monte Carlo simulation. The process, if you see and look at those steps of the process, set up the probability distribution, build a cumulative probability, establish interval random numbers of the variables, generate random numbers, simulate series trials. If you look at them, they are not far from the general process that we explained about simulation. That's why they were very generic, and they could apply to any type of simulation. Those steps that we explained earlier. These are more specified to the MCS. So you start by having the probability distribution, you set it up, and you build the probability distribution for each variable you have, depend on the variables you have set from step 1, and then you establish interval of random numbers. تعمل أرقام عشوائية in range, interval فترات عشوائية, and then you generate random numbers related or falls within those interval اللي انت يعني you set it in step 3, and then you simulate these values based on the probability you have set from number 2. Let's take an example and how we implement those 5 steps step by step in this example to show you how it's easy to do the Monte Carlo simulation. The daily demand for radial tires at a company or auto tire company over the past 200 days is shown here in this table. We can convert this demand to probability distribution by dividing each demand frequency by the total of 200, and that was the first step. You have the demand of the tires and the frequency of the days where the demand appeared. So I have zero demand, ما في ولا tires انطلب, for 10 days. I have one tire requested that's appeared or يعني repeated 20 days. 5 tires, 5 كفرات انطلبت, and that request appeared 30 days. So the appearance or the frequency of each demand is listed here. Now this was a total of 200 days data, and this is from the historical data we have. Now how we calculate the probability of occurrence? You basically divide the value of the occurrence divided by the total. So you divide the 10 over the 200 to get the probability of the demand of 0. So the probability of 0 demand is 0.05. The probability of 30 of 5 tires demand is 0.15. So if you add all these up, you will get 100, which is the probability of the total demands you have based on your data that you previously measured. So this is the first step. You set up the probability distribution for the variables. ايش الفاريبلز اللي عندي؟ الديماند حق التايرز. اوكي، هذا هو الفاريبل. probability distribution, you have to calculate the probability of the occurrence. In this case, it's listed here and it's given, so you have to calculate this column as the first step. These information are given and you calculate this side or this column as the probability of occurrence, اللي هو probability distribution for the variable. You do that as the first step. Again, how this calculated? You divide the number of occurrence divided by the variable value, related value. So I have demand one tire appear 20 times. So you divide the 20 over the total 200 to get the probability of occurrence. So you divide the 20 over the 200, which is the total of days or total of number of runs you have collect your measures or your data. Sorry, I think I said you divide the 20 over 1. That was, sorry, by mistake. 20 divided by the number of total days، لأنه أنت تبغى تحسب احتمالية طلب يكون 4 كفرات. I want to find احتمال يعني probability of 4 tires demand. كيف نحسبها؟ عندي data given. How I can calculate it? الفريكونسي ظهور 4 كفرات، اللي هو الطلب يكون 4 كفرات كأنه طقم مثلا كامل للسيارة، كان 40 مرة over كم؟ 200 days اللي أنا collected my data. So I divide the 40 over the 200, so I get the probability of requesting or demanding 4 tires. طيب أبغى probability ل 3 tires. What I do, I look for what was the frequency of having 3 tires was 60. 60 days. I had 3 tires ordered over the 200 days I collected. So I divided the 60, which is the occurrence اللي هو ظهور الطلب حق ال3 كفرات, over the total number of days I collected my data, and that will be 0.3, which is the probability of the demand that equal to 3 tires. So this is how you do the first step, which is the probability of distribution. You set up the probability. Moving to the second step in solving now the problem asks you to conduct the Monte Carlo simulation. You build a cumulative probability distribution for each variable. What does it mean? The cumulative probability different than the probability distribution. The cumulative mean considering the cumulative. ايش الcumulative؟ المجموع. What does it mean? The probability of zero demand is 0.05. هذا probability of distribution, هذا column of cumulative probability. You already did this in the first step. In the second step, you are going to do this cumulative probability. A demand for 1 tire, it will be equal the probability of 1 tire plus to the 0 tires. So 0.1 plus 0.05. And probability for 2 tires demand daily, it will be equal 0.2 plus 0.1 plus 0.5. cumulative تراكمي زي your GPA is تراكمي وفي معدل فصلي. هذا اعتبره كأنه هذا المعدل الفصلي. This one is the تراكمي cumulative. Okay. So 0.35, where did we get it? We get it 0.2 plus 0.1 plus 0.05. The same for the daily demand. The probability of the daily demand equals 3, it's 0.3. But the cumulative is 0.3 plus 0.2 plus 0.1 plus 0.05. And that's equal 0.65. Until you get the last one has to be equal to 1. Okay? So this is to verify your answer. So always the last one has to equal to 1. So moving to step 3, establish an interval of random numbers for each variable. What does it mean? Establish interval random numbers, and this is the concept of the Monte Carlo. The Monte Carlo is about that and the randomness. So when you do the random interval, الانترفال random اللي هي الفترات. So how we do interval of random numbers, we look to the probability column here, and we create a new column for the interval. We create a new column for the interval. We do the interval from 00 to 99, from counting, which means 100 numbers, but starting from 00 or 01, you can call it, it's okay, because you will count, for example, here the probability is 0.5, so you will count 5 numbers. So if you start from 00 and start counting 1, 2, 3 until 5, or you do from 00 and then you stop until 4. So whatever is the duration you started, but the common one is from 1 to 100, so you can always verify that your cumulative probability ends up with the interval random. So how we do the interval random, we start, as we said, to do intervals, فترات, based on the probability. You will do the counting. So if it's 0.05 here, so you will count for 5 numbers, and that would be the interval 1. For the second interval, there is probability of 0.1, so you will count for 10 digits or for 10 numbers, and that will be interval 2. And for the probability 2, the same. You will start to count for 20 numbers. So if you count from 16 to 35, that will be 20 numbers. So then for the 30, the same here, and for the 20, until you get the last one, which is the 0.15. When you add the 86, you will add 15 numbers to get to the 100. So the intervals, you do them based on the probability. The number of counts in the interval, it will be based on the probability, and always you verify that you will end up with the 100 if you start with 01. If you start with 00, you will end up with the 99 of the random. That's how you create or establish an interval random numbers for each of those variables. Moving on to step 4. Then you generate again random numbers. When we say random numbers, that means it's عشوائي. Okay, so you just do it in several ways. You can do it as you want. There is no limits of how many you are generating. Okay, now this is generated randomly. Those numbers, when you generate them, they have to be within the interval. So if the interval stops at 100, then the largest number here in the random numbers you generated, it has to be equal or less than 100. You cannot generate numbers that exceeding the interval you have built in the previous step. Okay, so these numbers are generated 52, 50. There is no sequence, no rules of how you generate those numbers. Okay, as you can see, 9 is here and 32 was before, and that even can done in some software that you can generate numbers, integers, from a range of where we start the interval from 1 to 100. and how many numbers you want to generate, let's say 70 or 80 numbers, then these can be generated using softwares. I think Minitab or Excel, maybe they can do somehow these, or you can just manually put random numbers over there, okay? Now, step 5, you start the simulation series of trials. What do we mean by the series of trials here? How we do the simulation? The series of trials are the trials here. He means this step, starting with 52, 50, 60, 52, and then 5. So you see the sequence. 52, he started with the columns. Now you want to columns, row. As we said, they are anyway random, so there is nothing hurt if you started in this way or this way. So he did it 52, 37, 82, 69. As you can see, they selected this column, 10 numbers from 52 to 90 as a sample simulation for 10 day numbers, and then the simulation will be started. How the column, those are from the previous step. You just add the column or the series trials in this column. But how these values being founded, the simulation demand or the simulated demand اللي هو الاحتياج او الطلب حق التايرز بناء على السيميليشن الان، not بناء على what happened exactly. So what you do, you go and see this number where it falls in the interval you have done in step number 3. The number was 52. So 52 falls between these two interval, between the 36 and the 65. So what was the demand? The demand was 3. So the simulated demand for 52 will be 3. Okay, what about the, let's take 98. 98. For the number 98, you go to the interval you have established in step number 3. 98 is in the last interval, and the demand at that time or at that interval is 5 tires. So you put the 5 as the simulated demand. Okay, the random number was, let's say, let's take another one here. 50, it will fall the same. So let's take 33. 33, you go back to step number 3. 33 falls between the 16 and the 35. So the demand of tires, the daily demand, it will be 2 tires. So you put 2 here. Okay, this is how you fill this column. Then you get the total at the end. So you add them all up for the 10-day demand, and that will equal to 39 total of 10-day demand. Okay, so that will be the demand, 39 tires as the total for 10-day demand. You can run that through all the generate numbers or series you have done in step 4. And here is the note says that the average, by the way, you just divide the total over the number and you will get 39 divided by 10, and that will be 3.9 is the average. If you calculate the expected demand using the probability from the first step that you have calculated, which is the probability of units, اللي هو probability of the tires times the demand of the units, كم كان الدemand for each probability, and you add them all up, you will get 2.95. How did we do this, the expected demand? We go back to the first table. So we multiply and add the demand times the demand here times the probability, and add them all up. We sum them all up. Okay, so you get the 0.1 times 1 by multiplying. We can take it from here since this table is copying or having the results from the first step. 0.1 times 1 plus 0.2 times 2. You are multiplying the probability times the number of units or the number of tires demand plus 0.3. So you add the expected until you get 0.15 times 5, which is the last value here, 0.15 times 5. You add them all up to get the expected demand. This is not simulated. This is the expected based on the historical data without running simulation. This, by having 10 days running simulations or random simulation using the Monte Carlo. Okay, there is a little slight different. 3.9 the average was, and here it was 2.95 tires. Why there is a different? The different is expected and predicted there will be a different. And the reason for that, it's written here. If this simulation here runs and repeated hundreds or thousands of times, the average of the simulated demand here, the 3.9, will be very close to the 2.9 tires, which is the expected demand based on the probability and the number of units. So the simulation here can do that thousands and hundreds of times, and it would be very close to the expected demand. So the simulation, this is maybe goes to the here when we talked about yes, here it's a repetitive approach that may produce different solutions in repeated runs, and that's an example shows you how when you had simulated 10 days is going to be different, the results, than when you simulate for hundreds or thousands of days. And how that will help me in here in real life or in this example, here I have only for those 10 days, and the expected was just the probability of occurrence of this exact demand. Doesn't mean also this is actual, this is expected based on the probability. يعني زي لما بنقول probability of the dice to have 5. إن رميت زهرة أو نرد، البروبابيلتي إنك تحصل على 5 حتكون 1 of 6 for the first time. If you have done it twice, third, fourth, 5, 6, 7 times, you have this probability calculated, and then you do the distribution that as you learn in the statistics. So then you can have the expected occurrence of 5 when you repeat it 5 times, as we did here. If I'm going to apply the probability calculation, this will be the expected based on my number of demands for the number of collected days I have, the 200 days. But if I want to generate or simulate for other hundreds of days or thousands of days, this also will not be inaccurate, but running the simulation can help you to predict for a longer time and many repetitions more than the expected demand, because that only will be based on the data you have collected. as the data you collected is high, as the expectation will be increased, but the simulation will use any expected, any historical data to generate it over a longer time and longer repetitions, and or more repetitions. So the average of demand of this simulation 3.9 is different from the expected daily demand. The answer why? Because here we just run it for 10 days trials only. Remember, when we generated in step 4, we generated here 50 days. We have just shown only when you selected the 10 days. You can generate over thousands of those numbers, and you can run this and you simulate that for thousands of times, and that average and this time will be very close to the expected demand, and even it will be close to the actual 1 over time, and closer to the expected demand. Again, this was only for one variable. So imagine when you have multiple of variables, that will be even more difficult to do it using that. Simulation will be easier than the steps. It will be followed easier. And this is how the Monte Carlo used the randomization. And you see the word of randoming comes اللي هو العشوائية in 2 steps, where when in step 4, when we generate the random numbers, also in step 3, when we generate the random interval numbers for each variable. And here in that example, we had only one variable. This is how the level you are going to deal with in terms of some examples or questions you are going to take for the Monte Carlo simulation. Again, this is not a simulation course. This is an introductory course for the industrial engineering. So we'll not go further in the complexity of the simulation. All these will be discussed in a separate course where you will learn more and you will practice more simulation using software application. And since speaking of the software application, there are very common simulation software examples like Simulate, Arena, or Pro Model. You are going to work with the Arena and in the simulation, as also you will explore some of those when you take the course. And you will all of them are available online, and there are many videos and tutorial about them that will help you to learn more about the simulation. And as I said, now simulation mostly done using software applications, and those are developed and improved occasionally to be more in user interface and has more advanced tools to analyze data and shows the decision makers results that help them to take the right decision or the right action, and also evaluate the scenarios and implement them easier by the time of the development of these software. But by this level, or at this level of this course, you are going just to deal with the basic concept of the or basic an example of Monte Carlo simulation by having implementing those steps from the probability of the variable, then the cumulative probability, then generating the interval, the random interval, and then generating the random numbers, and then calculate or run the simulation manually by calculating the simulated values for the variable by taking either a portion of those generated numbers that's set already in the question, or it gives you the window that to practice it at any number you choose. That's also give a different answer for each student when they take some examples for Monte Carlo simulation. I hope you enjoyed this session, and it gives you a different perspective and methods for the operations engineering. Thank you for watching, and we'll see you in a different application of industrial engineering. See you.